All right, so the first sheet is just a few different ways to represent data. And the first one's a dot plot, and all a dot plot is taking each one of these, I believe they're 20, you can count them and tell me if I'm wrong, and just putting a dot, don't put it right on the line, but right above the line. So 54 would be about there, 58, 60 would be right above the 60, 43, 35, 32, 47, 28, 33, 42, they're pretty tight together. 65, I was trying to get to one where it repeats. 73, haven't had 73, 44, 27. Is 27 a repeat? Nope. Wait, what was that? Oh, 28, 27. 32 is a repeat. So when you get to a second one, you would just put another dot on top of it, showing that they're two of the same number. But you can finish that off. That's not be kind of messy if I keep doing it. It's the stem plot that I wanted to make sure you guys know that, stem and leaf. So anytime you have a stem and leaf plot, or just called a stem plot, if all the numbers are in the tens, the stem represents the tens digit, and then each leaf represents the rest of the number. So since the numbers from 20 up to 70, your stems would be 2, 3, 4, 5, 6, 7. Your leaves are, if I go through, there's a 28, 27, 28, 25. Those are your 20s. And you want to put them in order. You don't do commas or anything. But so it'd be a 5, a 7, an 8, and an 8. And that represents 25, 27, 28, 28. Your leaves are only one digit ever. So if you had a 3-digit number, you would use 2 of the digits over here, and then the 3rd digit. So I know that's 4 pieces of data, and that handles all of the 20s. So then 30s, 35, 32, 33, 32, 35, 33. So there's actually 2 2s, a 3, 5, 5. 33, 32, 35, 3, 32. That's your 30s. And put them in order, and that way you can see modes also. 40s are 43, 47, 42, 44, 48. So it'll be 42, 3, 4, 7, and 8. 50s are 54 and 58, 4 and 8. 60s are 60, so you do 0 and 65, and then there's a 73. So that's what a stem plot looks like. And you can see that the bulk of it is up here, just like the bulk of this would be in this area. So if you're asked about skewed, think of it as if you laid it on its side, most of it's in this area, so this is skewed left. They ask you about skewed. So that's stem and leaf. Now there are bar graphs, bar charts, bar, whatever you want to call them. There's histograms. And they are different in that, if it'll ever change, bar graphs, each bar represents one thing. Where histograms, if you have a histogram, each one of the bars actually represents a range of numbers. And that range, like 25 to less than 34, since those were whole numbers, that's actually just 25 to 33, because there's nothing between 33 and 34. So that range of 8 numbers is sometimes called the bin, bin, or they also use the word, where is it? It's down here somewhere. Oh, class. But your bins are each 8, right? And I have the data in front of me, but so this is really, if you have 6 bins, I have like 12 spaces, so I can use 2 spots for each bin. And histograms, they go right up against each other, where bar charts, the bars are separate. So this first one is anything from 25 to 33. You see how it ends at 34, but it's less than, and then 30. So the number 34 would be in this group. So 34 to 42, 43 to 51, 52 to 60, 61 to 69, 70 to 78. And you can just use the tally marks. So the numbers were 54, 58, 60, there also, 43, that group. And that's, if it's 43, make sure you're paying attention to which one. This is less than 43. So 43 would go in that group, not both of them. 35, there, 32, 47, here, 28, first group, 33, that group, 42, there, 65, 73, 44, 27, 32. And since that's another one, I'm going to do that 5th one, line through it, so I know that's 5. 35, 28, 25, 48, and 33, back to there. So once you know how many are in each group, each bin, each class, there are 5, 6, 7, 8 here. You just do 8 blocks, right? 1, 2, 3, 4, 5, 6, 7, 8. And that would be, it's not a bar, but it's a histogram. That's your first group. And then 34 to 43, there are 3 of them. Oops, sorry about that. There's 3 of those. The next group has 4. The next group has 3. And then 1 and 1. And again, you can see all of the data is pushed over here to the left. So like we said, this is skewed left. So describe the shape. It is roughly symmetric. Everything would be in the middle. This is roughly skewed left. The spread of the distribution goes anywhere from 79 to 25 based on this histogram, because we can't, if you don't have the data, if I just gave you this histogram, you don't know whether this number is, well, 78. You don't know if this number is a 78 or a 70, or you just know there's one number in there. So the spread of this histogram is anywhere from 78 the highest and 25 the lowest. The center of this histogram, well, you can count up a histogram, the number. So if there's 8 here, like that was 8, this is 3, 4, 3, 1, 1, add them up and get 20. The center, if you have 20, has to be between the 10th and the 11th. That's 8. 9, 10, and 11 are all here. So the center of this must be from 34 to 42. the center is in this piece. Do they appear to be any obvious outliers? No, and we're going to talk about outliers, but if you have data that was just well away from the rest of it, that would be an outlier. That says no, that's a horrible no. What's the width of each class? Like I said, each class has a bin width of 8. And could this data be set? Yeah, you could take these 6 and set up a pie chart, right? 8 out of 20 would be your percentage and stuff. So a pie graph. So yeah, why not? Yes. Sure. All right. So there's another one right after this where you make sure your bins are all the same size. If this one's 8, the next one's 8, the next one's 8. You have to set those up yourself and then do your tallies, and not too bad. It does the first one for you, so the next ones will just all have to match the size. All right, and what I want to show you, it jumps down to 1416. This split stem, there are 2 different types of, well, a few. One of them, if you have like 2 groups, if the top were all the juniors and the bottom were all the seniors, sometimes you have a stem plot that's like a double stem or a parallel, where you put a leaf on one side and a leaf on the others. And then you put all your stems in the middle, and then like all the junior numbers would be over here and all the seniors. That's not what this is. A split stem plot is when you have this stem and leaf, the numbers are only going from, I think 35 is your highest and 0 is your lowest. So instead of just doing 0, 1, 2, 3, which would just give you 4 stems and a lot of numbers, they split the stems to 0, 0, 1, 1, 2, 2, 3, 3. Where this one, the first 0, actually represents from 0 to 4. That's 5 numbers, 0, 1, 2, 3, 4, 5 numbers. And then the second 0 is from 5 to 9. So this would be from 10 to 14, and then the next one would be from 15 to 19. So what I'll do real quick is go through and like 6, I'm not gonna put them in order, but you can do that later when you do yours. 7 would be in the second one. 26 would be in the second 20s. 16 would be in the second 10s. 2, 34 would be in that first one. 12, 0, you just put 0, 9, 9, 3, 9, 6, 12, 12, 34, 10, 9, 15 goes in the next one. 25 is that one. 0, 13, 11, 35 goes in the second group. 8, 8, 33, 5, 5, 3 again. 9, 15, 8, 15, and 6. So even with splitting them, this is a big number. And if you thought about this, laying over on its side, this is definitely the bulk of it is on the left. You thought about 0, 0, 1, 1 this way. Most of the data is there. So this is definitely skewed left. So describe the shape, skewed left. The spread is anywhere from 35, well, that's the high, from 0 through 35 is the spread. And the center of all of those numbers, I don't even know how many numbers there are. But you can find the center, find out how many numbers there are and stuff like that. Obvious outliers. No, this group is up here by itself, but it's still a few of them, so I wouldn't call that outliers. But that's that first page. On the second page is the box plot stuff. And you don't need to put this in a calculator. Probably quicker if you don't. If you just understand how box plots work. If it ever changes. All right. So remember, Boxplot has a 5-number summary with this is the minimum, that's Q1, the median, Q3, third quartile, and the max. First thing you want to do if you have a list of numbers is find the middle. And if there's 13 numbers, if it's odd, think about one less. So 12 would be 6 on one side, 6 in the other, 1 in the middle. So it's the 7th number from either side is the middle. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It'd be the same. So 3 is your middle number. Now, if one of your numbers is actually the median, you don't count it anymore in the rest of them. So now there's 6 at the bottom that I have to find the middle of for my first quartile. And if you have an even amount of numbers, the middle will be in between 2 of them. So if you have 6 numbers, the middle is between the 3rd and the 4th here. Right between 1 and 2 is, of course, 1.5. And the top half, the middle of 5 and 5 is 5. Your minimum number is 0, your maximum number is 7. Don't count those out when you do the quartiles. The only one that gets taken out is the median. So those in numbers are included in the quartiles. If you're going to do a box plot, you then above the line put a dot for every one of your 5-number summaries: 0, 1.5, 3, 5, 7. Put a line through the middle 3 dots, so the dots in the middle of the line, and make the box, and then whisker out for the whiskers. And that's it. So it's just dealing with odd and even numbers. Like on the next one, there are only 12 numbers. So if you have 12 numbers, you would have 6 on the bottom, 1, 2, 3, 4, 5, 6, and 6 on top. And so your median is actually right in the middle of those 2. And if you're not sure, you can always add them together and divide by 2, but 2 and 3 is 2.5. This time your median is not one of the data, which is fine. So it still leaves 6 and 6. So the middle of those 6 is here, 1.5. So there's your first quartile. The middle of the upper 6 is here, 4.5. Your upper quartile, and then your minimum and your maximum. 0, 1.5, 2.5, 4.5, 7 are your 5 numbers. The middle 3 become your box, and out to your whiskers. And same every time. So there's 2 more of those to do on your own on that sheet. And then you get to the part about the outliers. And some people look at outliers as just like, is it an obvious outlier? But there's an actual formula to find outliers. But before we can use the formula, we still need our 5-number summary. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces of data. 1, 2, 3, 4, 5, 6, 7, 8. And in the middle, so there's 8 on both sides. Right in between 21 and 22 would be 21.5 for your median. The middle of these 8 numbers at the bottom is in between 19 and 19 would be 19. And the middle of the group up here is between 29 and 33. So again, you can add those together and divide by 2, or 31, or just figure out what number is in the middle of 29 and 33. 31 is. So 0 is your minimum, 54 is your maximum. Now, to find out if any of these numbers are outliers, to be an outlier, you have to, well, let me show you the middle part of this. So 19, 21.5, and 31. This is the box part. That's the inner quartile range right there. If something's an outlier, it has to be 1.5 times the distance of this box away from the end of the box, and then it's considered an outlier. So the way you figure that out is first, what is 1.5 times? Well, this box, the inner quartile range is 31 minus 19. Borrow 11 minus 9 is 2. So it's 12. So what is 1.5 times 12? 1 times 12 is 12. Half of 12 is 6. And 12 and 6 add up to 18. So 1.5 times 12 is 18. So if you start at the lower one, which is 19, and you subtract that 18, you get 1. So any number that's below 1 is considered an outlier. So this 0 is considered an outlier. Same thing here. If you start at the upper quartile, 31, and add that 18, 31 and 18 is 49. Any number above 49 is considered an outlier. So this 54 is also an outlier. And the way we graph outliers is you still put it on the graph, just don't connect to it. So since 0 is an outlier, 6 would be the next number that's not an outlier, and that's where your whisker goes. So when you look at this box plot, you can see, oh, there is an outlier to the left that's skewing the data to the left. Also, 54 is an outlier, so I put a dot, and the next number that's not an outlier is 45. So the whisker would only go to that 45, and then that's an outlier. So if you talk about like, is this data skewed left or right? Well, since it's being pulled by outliers in both directions, it's really not skewed to the left or right. But that's how you do outliers. 1.5 times the inner quartile range, IQR. All right, so any questions on that? I think that's the last thing.